And I'm going to talk about the gradient of a curve. And in the previous activity, you might have come up with how to find the gradient of a curve at a specific point. And so we are going to go over another investigation, which basically I'm going to actually walk you through. And I will be using autograph for this one. And let's get started with, first of all, the polynomial function. If you remember in the previous activity also, I started the lesson with how to find a slope of a line. So I'm not going to spend too much time talking about that. So if you need to review, go back to the previous video and you can check that, how to find the gradient of a line if you need to. So I'm going to start with, basically we do not have that many lessons. So what in the lessons which we have, I'm going to just do the gradient or gradient of a polynomial function actually, and to start with linear function first. So you know the standard form of the linear function is y is equal to ax plus b, and we are trying to find what is the slope of this, which you already know that, and you know a is the slope and b is the y-intercept, and the another name for slope is the gradient, which we also talked about in the previous lesson. So here is the graph for y is equal to 2x minus 3, and you know that how to find the slope using a equation, which is the coefficient of x, which is 2, or you can also use the diagram to do that very quickly again. So one more time. So if I draw a right angle triangle here, so you can see this is going right and then up. So the slope is positive, and this is 2, rise is 2, and run is 1. So therefore the slope is 2. So which means I'm going to now, in the previous lesson also, I introduced a new notation, which is f of x. And I said that f of x is same as y. The only difference is when you have a relation which becomes a function, we use f of x. I'm not going to go in detail like when the relation becomes a function, so we will not be talking more about it, but f of x is just a y. So f of x is equal to 2x minus 3, and we know the slope in this case is 2. So I'm introducing a new notation here. So the new notation to represent the slope or the gradient, and then one more name is the derivative, is f prime x. So you have f and then you have dash, f dash x, which is equal to 2. So this is how we say f dash x. So there are three ways of calling f dash x or f prime x. The first is slope, gradient, and derivative. All of them is exactly the same thing. Now, if you look at here, this is again the equation of a line, but you can see the slope is negative, and you can find out the slope again because the equation is not given, but you can actually, when the graph is given, you can find the slope. You can also write down the complete equation. So in this case, slope is -3, so we'll say f dash x is -3. So the slope of a line is a constant number, and which makes sense because what is slope, derivative or gradient or rate of change here, since it's a linear equation, it's a line, so the rate of change is constant. So that's why you got f dash x is equal to -3 here. Now we are going to move to the quadratic function. Now what happened is, when you have a quadratic function, the shape of quadratic function is the parabola, which means here it's tricky. We know how to find the gradient of a line, but we do not know how to find the gradient of a quadratic functions. Hopefully from the previous activity you should have got some idea, but I'm going to emphasize on that again, and that's why I'm doing this investigation, so that you will have, if you understood from the last activity, then it's kind of a review for you. But if you did not understand from the last activity, then hopefully with this activity it will be much clearer to you that how do we find the gradient of a quadratic function or the gradient of a curve in particular. So for quadratic function, the standard form is y is equal to ax squared plus bx plus c. I mean, you can find the gradient in kind of like two different ways. The first way, first I'm going to talk about the first one, and I'm going to use autograph for that. I just wanted to show you, I did not have autograph for some reason. The school subscription of autograph was not working for me, but then I found the autograph 5 actually. You know that you can download it the free trial. Before it was like 20 days or 25 days, but right now it's free. And so what I did is I downloaded the Autograph 5. But if you are using school laptop, then you might need the permission from help desk. So go ahead and do it. You don't have to, since I'm going to show you how to use Autograph to do the how to find the gradient of a quadratic function, and hopefully you will be able to see the relationship and the pattern when I'm doing it. But if you have an Autograph and if you're willing to download it, then you can also try this investigation on your own. So let's have a look at, so the quadratic equation. We want to find what is the another important thing before I move to the next step. If y is given as instead of f dash x, sorry, f of x, so if y, the function is given as y is equal to, then for derivative or gradient or slope, we use y prime. And if you have f of x, which is given as a function, then for derivative or gradient or slope, we will use, the notation we'll use is f prime x or f dash x. So please keep that in your mind. And if it's y, either we use y prime or y dash, or we can actually also use dy divide by dx. So this is the another notation for derivative function. As I'm talking through different notation and different things, I hope that you are taking notes in your notebook, because the for today's lesson, your task will be to upload your notes. And if I ask you to make a table, then you make a table. If I ask you what pattern do you see, then you describe the pattern. So that will be your today's task. So make sure that at any point, if you need to pause the video, or at any point you need to go back and see the video again or the previous video, make sure you do that. So your task for today's lesson will be to take notes and then upload those notes as your task. So now I'm going to move to, so if you have y is equal to ax squared plus bx plus c, so we are trying to find like what is y prime for those quadratic functions. And to do that, I'm going to start with the simple example. And y is equal to x squared is a parent quadratic function, and because it's very easy to sketch, and you should know actually how to do it by hand also, y is equal to x squared. But now what I'm going to do is I'm going to use Autograph to do this. And pay attention to, I may not be able to make a table, but maybe I will be. So make sure that when I ask you to do make a table, you do that. And then at some point again, you need to go back and review everything and put things in order. So I'm going to first, when you use Autograph, you don't have to use Autograph, but it's more interactive and it's easy to understand. That's why I'm using this. You can also do this activity using GDC, but with GDC you might not be able to do all the things which we can do using Autograph. So that's why I prefer to use Autograph. I think the another alternative will be, you can also use Desmos to do that. But I again, I'm not sure that the steps which I'm going to show, if you can use you if you can do using Desmos. But Autograph is very, very important, and it's very useful. And when you go to your DP classes also for your internal assessment, which will be kind of your exploration, the Autograph is very handy because you can do a lot of things using Autograph. So I'm going to choose a two-dimensional new 2D graph, which I already have. So after you have 2D graph, I'm going to enter the equation. There are multiple ways to do it. So I'm going to write y. You can use your keyboard to do that. So y is equal to x to the power of 2. As you can see, I got that y is equal to x squared. This is the another way of entering your equation. And after that, I don't like the window setting of this, so I'm going to change it to, and actually it is also given here. Once you have that, you need to change your window setting to, this is given here, so I'm going to go with that, -5 for x. So I'm going to change the added x's, and then I am going to change this to -5 and 5. And then I think this was 0.25. Let me look at 0.25. Okay, I'm going to log that. And now I'm going to see 5, 1 and -5, 20. So this one is a -5 and this is 20. And if I understood, or if I remember, this was 5 and this is 1, and then you lock it and then okay. So this is how the graph look like. So this is the setting which we have, and now what we need to do is we need to enter points on the curve. And to do that, what we do is we need to select it. When you select it, you just click on this, it will turn into black, and then you right click, and then from here you can enter point on the curve. I'm going to enter 2 points here, starting with 1. So if x is equal to 1, okay, so x coordinate is 1. Why it's not giving me here? Okay, let me first do x is equal to 3 then. Okay. Okay, it looks like something is wrong. Let me try again. Enter point on the curve. And then x is equal to 1. Maybe I need to lock. Let me see. Okay. It seems something is wrong. So you enter 2 points. I'm going to enter, when I enter x is equal to 1. So you need to, first thing you need to do is you need to select it so that it turns out to be black. And then you right click and then you enter points on the curve. So I'm going to enter 2 points. The first point which I entered is when you click on this, you click on x is equal to 1, and then it will automatically read your y value. And then similarly, you do x is equal to 3. So I will show you here. So I already have x is equal to, as you can see here, it's like 1.1. I couldn't put it back, but x is equal to 1 when I did that. So it will automatically give you the value of y. And similarly, when x is 3, y is equal to 9. Now, after you got these 2 points, then what you need to do is you need to select this point and then press on shift and select the other one, and then you right click and then you go to line and then you choose gradient, and then you will see the right angle triangle. So after that, what you need to do is, if you look at here, y is equal to x squared, the equation is given here. If I move this point here, you can see here, you can see x is 1.1, it's not 1, but if I move it further, it will be 1. 1.21 is the y because y is x squared. And then you have gradient, which is 4.1, which you can see from here. And delta y means y2 minus 1, difference in y values, and delta x is the difference in x values. So what I want you to observe is when I move this 1, 1 towards 3, 9, so check what is happening to the gradient. So what is happening here? When I move it, so check the gradient. So as I move it closer to closer and closer, so now the gradient becomes 5.5. And now the gradient is 5.8. And if I move it further, even more closer, it's 5.9. And if I'm going to move it even more closer, then it will be 5.9 something, 91 or 5.92 or 5.93 or 5.999. So this is going to be very closer. So what I want you to do is please note down that make a table here. So I'm going to just show you very quickly. So you make a table here, and here we are going to write down y is equal to x squared because this is what we are trying to look for. And you have your x value, which is 1. And what I want you to write down is when x is 1, y is 1. And then your gradient in this case, no, so sorry, when you have 1 and 1, sorry, we need to do this again. So when you have x comma y, okay, and then when you had this as 3 comma 9, why? Because your equation was y is equal to x squared, and you moved from, and we fixed 1 comma 1, and we are approaching this 1 comma 1 towards 3 comma 9. And then I want you to record what was f dash x, and when you record it to the nearest whole number. So in this case it will be 6. Now give it a try. Change this number to x is equal to 2, and then your y is going to be 4, and then note down what is your gradient here. And then you move it to 4 comma 16, and then you find out what is the gradient here. and then so on. So maybe 2 comma 4, you should start with 2 comma 4 first. And if you do 2 comma 4, which I don't know if I can do now, let me see that. So when it is 2 comma 4, if I change this point, if I can do that. So if I change it, this one, let's change it to 2 comma 4. The easier way will be to actually do it from, so if I choose this, hopefully it will work. If not, then you can try yourself, or you can have, so if I enter, okay, and added coordinates. So if I do x is equal to 2, let's see if it works. Okay, so for some reason it's not working, it was working before. So if you have x is equal to 2, so I'm going to change this to x is equal to 1. Okay, so if you move, it's a bit hard to show on this laptop, but x is equal to 1 and then x is equal to 2. So if you change it, x is 2 is here, okay, and then so this is 2 or 4, but then I want this to be at x is equal to 1 here. Okay, and then you can see here the gradient is, what is the gradient here? If you have x is equal to 1 and then you have the another coordinate which is 2, then what is the gradient here? So the gradient in this case is 3.1, but if I move this closer to, so your gradient is going to be, if you pay attention to, it's 3.8 and it's invalid if it overlap. But then if move it closer and closer, maybe you zoom out and then you can see here and record that in your table to the nearest whole number. So I'm going to do that one more time, the recording, if I can do here. So let me write down here. So this is what I want you to do. So x, y, and then we have 2 comma 4, and then we notice the, sorry, not x comma y is here, so let me do it again. So x comma y here, use bracket here, and then you have f dash x, and then for 2 comma 4, and how did we get 2 comma 4? Because the function is y is equal to x square. Your gradient came out to be 4, nearest whole number, and then when you did 3 comma 9, this came out to be 6, and then when this is 4 comma 16, hopefully you will see that this came out to be 8. And now go ahead and do more, maybe 5 comma 25, and then you will see that gradient came out to be 10. Now pause the video here and try to see what is the relationship here. Can you find a general rule? So if I look at this thing, pause the video here, and I'm assuming that you are back after you took the pause. So if you look at 4, 6, 8, and 10, the y dash values, or f dash values, then we can see this is a linear pattern, increases by 2. So f dash x is equal to 2x. So if you have x square, then the derivative is 2x. Sorry, not, yes, 2x. So f dash x is equal to 2x. So hopefully you found this general rule. So whenever you have y is equal to x squared. So basically what we did is, from one point we fixed the another point where we wish to find the gradient, and we moved this point closer to that point. Then instead of the triangle, we got a line which is called the tangent. And this is what in the previous you should have come across that as well, because right now this is a chord and we know how to find the gradient of a chord, but that's not what we need, because the gradient of a curve is different at different points, as you should have observed from the from what I was explaining. So if, depending on whatever is this point, the gradient changes, and then we were able to find the general rule for y is equal to x squared. And this will be the situation. Now instead of a chord, we'll have a line which is called a tangent, which basically is a line which only cuts a graph or touches the graph only at one point. So with that, we already know the gradient function for x squared is 2x. Now if we want to do 3x squared plus 2x, you can do the same using autograph. You can do the same thing which we did already. So you can do the same thing, or what else you can do is, already the derivative of x square, which is 2x, So, and you also know the derivative of 2x is 2. So the derivative of x squared is 2x, and the rule of 3 is it will get multiplied by 2x. So the f dash x in this case is going to be, so let me show you. So here the f dash x in this case is going to be 6x plus 2. In this case, because what I'm doing is I'm breaking this into two different functions. So this one is linear, and we know that the gradient of linear is 4. And we know the gradient of x squared is 2x. So when you have 3 in front, then this becomes 3 times 2x. So then it will become 4 minus 6x. And then similarly for this one, it's going to be 4x, because for x squared is 2x, and then for minus 3x, it's minus 3. So that is your f dash. And then for this one, this is going to be minus half, and then you multiply minus half multiplied by 2x plus 5 plus, plus 5, and then 2 and 2 get cancelled. So this will become minus x plus 5. So that is your gradient. Okay. So similarly, you can explore for other cubic, quartic, and quintics. Like when the degree is 3, what will happen? When the degree is 4, what will happen? And when the degree is 5. So you can use actually, so that is what I would like you to use, that using this program, which is called Wolfram Alpha, and you can you can write down derivative of y is equal to 3x cubed plus 2x minus 1. So please give it a try and find out that what is the derivative of y is equal to 3x cubed plus 2x minus 1. And once you will have, this is the link to the website. So obviously you won't be able to click on this link, but what you can do is you can type in your search, and then you should be able to use this site to find out the what do you notice here for cubic, what do you notice here for x, 2x raised to power 4. And once you have noticed that, your task will be to give me the general, what is the derivative for the general polynomial function given below. So this is what you have to do. So very quickly, very quick recall, we started talking about the polynomial function. I'm not going to go much more in depth here. You know how to find the gradient of a line, because that's something which we do in previous years using the graph or using the formula. And then we introduce the new notation, which is f dash for derivative, for slope, gradient, different names. And then we were exploring for quadratic function, and we started with y is equal to x squared, and I used the autograph. Again, feel free to use the autograph, and taking notes, making a table, and the general rule which we talked about for the x squared, you need to mention that in your notes. And then after that, you can try for these functions using the same autograph. If you don't want to use the autograph, then the way I explained it, by splitting it into linear and quadratic, and you already know for x squared, but I told you when it's 3x squared, the only difference is you multiply 3 by 2x. So now you record these functions and their derivatives also in your notes, and after that you need to try this site to find out what are the rules for this one, and then you will complete the derivative of a polynomial function. So that's it for today's lesson.